This is Dr. Erica, and welcome to our kitchen. Today we are doing the color changing juice. So we've got one video on me so you can see what's going on, and if you look right there, we have a little picture-in-picture that will show you all of the lab book from the top down. So you have this beautiful lab book that starts a mystery, and we wonder what Rosie made. So far I have cut up some purple cabbage and I boiled it for 10, 15, 20 minutes, but it becomes this dark purple, dark bluish color. So now we're ready to start our lab. So in the mystery, Rosie adds something. She thinks she adds water to her lab, or to her juice, and it turns pink and it tastes disgusting. So the first part of our lab, which is right here, is going to say, let's add some water and see what happens. So I actually have a bunch of these cute little cups that are pre-filled with small amounts. If you're doing this with kids, these are great because it's kind of an easy way to make sure that they're not adding too much of whatever it is or too little. You can kind of control it a little better for them. So right here I have some water, and I've got my little droppers, which are a lot of fun for the kids to do as a little extra activity. So we're going to just take this and drop it in. And it looks like there's not very much that's happening. It's still purple. It's a lighter purple, which would make sense because we're adding a lot of water to it, but it's still purple. So my red cabbage juice plus my water is going to be purple. I have a box of crayons. These are just Crayola 24s. And I'm just going to color in my glasses. It started off purple, and when I added water, it was purple. And then the next it says, what do you think Rosie added? And this is a great time for your kids to start learning how to make something called a hypothesis, to just make a good guess. They can guess anything they want. I would say try to guide them in the idea that it had to look like water, so it needs to be a liquid, should probably be clear, but they can add whatever they want. You can write it in right there. So everything that you see in our grocery stores that are purple or blue contain a molecule called anthocyanin. And the anthocyanin is what gives that beautiful color. So beets, purple carrots, blackberries, even wine has it in it. And this molecule has a lot of free electrons and a lot of abilities to kind of morph and mutate. And we're going to add all of these chemicals. We're going to change the charges. So we're going to make something either acidic by adding a lot of hydrogen ions, or we're going to make it basic by adding a lot of OH ions. So the hydrogens are positive, so we could add either a bunch of positive charge or a bunch of negative charge, and that's going to change this molecule. And by changing the molecule, we're going to change the color. So I have this pH scale on the bottom of the lab for you guys, and what you just need is just any sort of pack of crayons, and you just want to line up kind of one crayon with every color so that you know what colors you're going to be doing for everything. Because we're going to color in, we're going to make a color chart with all of the things that we test. So these will be the colors that I'm going to use. Now, I have the water, which I did, and then we had a little bit of a slight issue, a little tech issue. So we're going to redo the water, so we can put it up here so you guys can see. So our water is purple, which is neutral, which is really good. So now's the fun part. We're going to add in a lot of stuff. So here I have dish detergent, and you have this beautiful laid out table where you guys can learn to record everything. And that's a really big thing in science, is recording what you see and trying things again and again and making ideas of what will happen and trying to put together sort of, oh, what do cleaners, are they always acidic? Are they always basic? This right here is dish detergent. So I'll just write in dish detergent, and then I will add in some of my purple cabbage juice, and we'll see very quickly that it is no longer purple. In fact, it's pretty green. So I can take my green crayon and I can color in my cup the color of green. And then the next piece is to take that and look at the numbers on this pH scale. So it goes from 0 to 14, and green says that it's about a 12. So this is going to be a 12, and that is basic. So then I'm ready to test my next thing, which here is vinegar. And when we add the vinegar in, it turns a beautiful and lovely pink. And you'll notice that vinegar also happens to be clear and a liquid. So this is what Rosie added to her drink. And if your child didn't make that hypothesis and they didn't guess that at first, that's totally okay. Let them guess what they're going to guess and let them try it, because science is all about being wrong and all about trying again. So that was my vinegar. I'm going to write that down. And I'll give that a 4 on my scale, which is acidic. Let's see, next I have some Tums. This was one of my daughter's favorite things to test because she got to get out the hammer and smash it. And that's something that's really fun for the kids. You can do anything. You can do hair gel, you can do shampoo, you can do shaving cream. But she had a lot of fun smashing this up. And if we think about what an antacid is, we would think that it's the opposite of acid, so it should be basic. So we can kind of make a guess that I would guess maybe it's somewhere blue, green, or yellow on here. And so we can add in some of our cabbage juice and swirl it. This one you've got to swirl around a little bit to kind of let it dissolve some. And you see as I'm swirling it, it's actually changing color. It went from a purplish to kind of this milky blue. Now the milky part is just an artifact of what is in that Tums tablet. Not everything that we have will be nice and clear, but that's definitely a blue. And I can look at this and maybe say, I don't know, it's not an 8, it's not super dark, but I don't think it's a 10. So I'm going to actually give that one a 9. So we'll color this one in with the blue. And since I'm going to be a 9, I'm going to color it in with kind of both colors of blue to change that shade a little bit. And that was my Tums. And we gave that a 9, which is basic. And that makes sense because we take that when we have heartburn, and acid gives us heartburn. All right, so our next thing is going to be baking soda. And baking soda we always mix with vinegar, and we make a gas called carbon dioxide. And that's what raises up all of the bread that we bake and cookies. Okay, maybe not cookies, because vinegar is not in cookies. But when we make the bread, it raises the bread and gives us the bubbles. Baking soda is sodium bicarbonate. And what happens with sodium bicarbonate when we put it in water is it ionizes. So what we get is sodium, which is a positive ion, and we get something called H3CO3, I believe, which is just a molecule. It just hangs out. It doesn't do anything. And we have OH minus, which is a negative ion, which also happens to be that one that I talked about earlier that made things basic. So we can guess that this will be basic. But of course, if you're a scientist, you want to guess and check. So let's see what we get for baking soda. And it looks like it's turning blue for us, which is pretty awesome. And that's like a nice dark blue. So that's actually less basic than the Tums was. So here we're going to write in baking soda, and we're going to add in our dark blue. And because it was right next to my baking soda in the cabinet, I also have baking powder. Now the difference between baking powder and baking soda is that baking powder is sodium bicarbonate and 2 different acids mixed together. So I actually have no idea what this one will do because it's a base with 2 acids mixed. So let's see what we get. We're getting some fizzing. If you look in from the top in that little picture, it's fizzing up for us, which would make sense because we have the base, the sodium bicarbonate, that's reacting with our acids to make carbon dioxide, just like what happens when we add the vinegar and the baking soda. It's kind of looking like this is a little bit blue to me. Yep, it's a little blue. It's very light blue. Oh, it's warm. That's really cool. I would not have guessed that. It's really warm. All right, so we're going to color that one in blue. So baking powder. And we'll color that one blue. I'm going to give it, I think I'm going to give it a 9, just like we gave the Tums. So we'll kind of do the dual color here. We'll give the 9. Ooh, I forgot to give baking soda, so we'll give that the 8. And those are both basic. All right, next we have salt. And salt is our positive sodium and a negative chloride, and they're stuck together and they really love each other. So my guess is that it will probably be neutral because there's not going to be a whole lot. There's no hydrogens or hydroxides, the OHs that are in salt. So we wouldn't think it would change it acidic or basic too much, but it's always good to check. And indeed, it is purple. There we go. So that one is going to be neutral. So we've got salt, and we'll give that the 6 for being neutral, and we'll give it a little bit of purple. And lastly, I have a common ingredient in a lot of bath salts, which is citric acid. And given the name, we would think it would be acidic. So let's take a look, and it is definitely very pink. In fact, I'm going to bring over the vinegar to compare it to. I think this is more of a red than it is a pink. So if we look from the top down, right there, the vinegar is much more pink, while the citric acid is red. So I'm going to give the citric acid the most acidic, which on our scale is the 0, and that was red. Now, once your kids have gone through this, and they might want to test more things than this. My daughter did this for hours, literally hours on end. We have some extra indicator pages that you can print out, and they're just blank pages with all of the little glasses they can color in and the pH scale at the bottom, so they can do as much as they want. But once they do that, then they can start sorting things. So we've got strongly acidic, weakly acidic, neutral, weakly basic, and strongly basic. It kind of goes in the same direction of the scale as our pH scale. And you guys can just go through and write these things down. And hopefully you can start talking about things. All right, so now that we've tested a lot of single chemicals, now we get to do what my daughter thought was the most fun part, which I like to call some chemical math. So you have a page that has a bunch of different glasses, and they can add things and see what happens. And there's a couple of questions that they can try to follow. So the first one is, what did she add to get it to be pink? And so we know that that was vinegar. So we can write in vinegar. And we can add some vinegar. I've got some vinegar right here. So we'll add in some vinegar, and it will go pink for us. And then it says, what will she add to make this go back to purple? So the way you need to think about this is if we're acidic and we want to go back to purple, we need to pull it back. So we need to add something that's basic. So I could try adding something like baking soda, which would be a lot of fun because it's going to be very fizzy. And so I've got some little bit of baking soda here, and we can add in a little bit. And as it bubbles, we can see what's going to be happening to the color. So I'm going to add some more. I don't want to add it all at the same time because then this is just going to overflow for us, which it might do anyhow. We've got some good bubbles, and the kids, they love bubbles, right? So this is a really fun one to do. Maybe if you're impatient and you want it to go a little faster, you could add something more basic. But as we're looking at it, it's not quite as pink as it used to be. It's more of like a purplish pink. So we're going to add a little bit more, and we'll see if we can get back to that purple color. And it does indeed look like it's starting to change some. Let's add some more. And it's really fun to kind of watch them go from one to the other. And there we are. We're kind of back at a nice purplish color. So I can add baking soda. And the important thing to note here is they can add anything that's basic. They don't need to add baking soda. They could have added other things that we found basic. Like, for example, we have our dish detergent that was basic. We had our antacid that was basic. We had baking soda and baking powder. Those were all basic. So you could add any of those things and it would turn it back to purple. And once they start doing this, they'll probably love it. And so there's some things that you can just do. You could say, hey, let me add in, now that it's purple, I'm going to add in the dish detergent, and we'll see what that does. And so I can add in some of this dish detergent, and we can see what sort of color that turns us. And that to get to a much darker purple. Maybe I want to add a little bit more. And you can choose how much you add each time. And so now we're getting to blue. So I can color in that when I took this and I added it, I went to kind of a bluish color. So I can color that in. And let's say now I want to go the other way. We found that the citric acid had very acidic qualities. So maybe let's see what happens when I add in a nice little scoop of citric acid to this. We're getting a lot of fun little reactions here, and you see that very quickly. It's changing back. It's pulling it back to the acidic side. So we can add as much as we want, and we can see how much do I have to add. Now, one kind of fun thing about this is if you're adding like maybe a teaspoon every time, how much does a teaspoon get you? When you have a teaspoon of vinegar and you add a teaspoon of baking soda, does it completely cancel out, or does it just pull it a little bit? Does it pull it all the way to the blue? So these are all questions that you can ask. So I have my citric acid, and to be honest, that really kind of turned it a pinkish color. So we'll do that. And you can just keep going with these, and they have a lot that they can fill in as much as they want. And then we have this other question down here at the very, very bottom, and it says, take your cabbage juice and make it blue. And so what your kids are going to need to do is they're going to need to look at their pH chart and say, okay, blue, to get blue, that's an 8 or a 10, so that's basic. So I need to add something that's basic to my cabbage juice. So let's get some cabbage juice in here. And let's add something that we know is basic. So we'll add in our baking soda. We can add that in and swirl it around. And there it goes already. Just a little tiny thing. So there's the blue. So here I can write down, okay, I added baking soda to get it blue. What do I add to get it to go to pink? Well, I could add some citric acid. And so this one's kind of another little fun little mystery for them to try to solve and see, can we figure out how to make it go into all these different directions? And there it goes, right back to pink. So we're gonna add the citric acid, and that made it pink. And now I wanna make it yellow. Just so happens that our dish detergent, which used to be green, has had a little bit more time to react, and now it's yellow. So we'll add in some dish detergent, see if we can't make this turn into yellow for us. Let's see. I have no idea how much. Ooh, the dish detergent is really basic. Look how quickly that turned it. That turned it really fast. So we're going to add a little bit more in here. And there's other things in your house that are really basic. For example, bleach is highly basic, so that will turn it yellow instantly. Of course, then you have bleach around your kids, so it's kind of a toss-up. When I did it with my daughter, she was able to pick anything under the kitchen sink, but I had to do some of them. So I did the bleach, and I did the really harsh cleaners, and she did the hair gel and the shaving cream. All right, so once we've finished sort of doing all this fun chemical math, and once they're done with that, don't need to rush them through it. The last little bit is a I Spy adventure in chemistry. So I've got the colors of the anthocyanin molecules and their conformations at all these different things. So basically what you want to do is see how many changes can you spot. And changes include things like charges appearing. So for example, there's a positive charge when it's acidic that's not there when it's less acidic, and also not there when it's neutral or when it's basic. Another thing would be maybe a double bond that's changing. So if I look at this and try to find a double bond, let's see. Here's a double bond that appears between these two. And so they're just going to go through and find as many as they can. Here's an OH molecule that turns to an O negative. So it lost a hydrogen ion. So you can go through and see how many of those things can we find between all of these different conformations and colors. And then the last one is kind of regrouping and talking about the mysteries, seeing what did she add to her smoothie or to her juice. How do you think these things will taste? So things that are basic, so things that they can taste that are basic, maybe baking powder or baking soda. Do they like the taste of that? Does it taste good? Does it taste bad? What about acid? So what does vinegar taste like, or lemon juice taste like, or hot sauce taste like? And a lot of times the acids are very, very tart and sour that they'll find, and the bases are very bitter. And so trying to figure out how does our taste buds react to pH and to acids and bases, and what do they think Rosie's drink would have tasted like? So something to keep in mind with all of our labs is this is not just a sit down and do it in 10-minute kind of a lab. We want to train your kids to be scientists, And so it took my daughter probably 3 hours overall. We did it in a few sessions because she kept wanting to come back to it. So you don't need to force them to sit and go through the whole thing. Do a little bit and say, oh, that was really fun. Maybe tomorrow after school we'll sit down and we'll do the math part where we'll add in all these different things and do the chain reactions. Maybe tomorrow after school we can sit down and do the I Spy. Don't feel like you need to sit down and do it all at once. You want them to be comfortable. You want them to have fun. The most important thing about all of the stuff we do is that everybody has fun, that you guys enjoy it. So if somebody's not enjoying it, turn it off, regroup, come back, see if you come at it from a different angle. Hopefully you enjoyed our color changing juice mystery, and we'll be creating more labs like this for you guys in the future. Make sure to come on over and join our Patreon page, become a patron so you can get all of our labs delivered into your email inbox. It's $10 a month, and you'll get a lab a month to do with your kids. Everything is going to be fun and interactive, and it will always come with a mystery to draw them in. Thanks so much. Have a great night.